All right. So aldol reactions can also happen through an intramolecular process, as you would probably guess. So let's just take a look at an example of that. So we've got this as our starting material, and then we're going to add some sodium hydroxide and then think about what our products are going to be. So the general rule of thumb is that 5 and 6 membered rings are favored. So generally we don't form anything less than 5 membered rings. You can form more than 6 members, but it's not as common. So if we think about, putting our, having this be the nucleophile and then this be the electrophile, that'd be 1, 2, 3-membered ring. And so that'd be highly unstable. So where we're actually going to form our base is over here. So when we add our hydroxide, this is the hydrogen that we're going to deprotonate. To form our aldol. So we're going to go over here, attack, and then this one's going to come over here and then attack there. And then if we count our carbons, 1, 2, 3, 4, 5, 6. And so it's carbon 1, carbon 5 bond, right? So numbering your carbons and being able to keep track of that is very important. And of course, there's going to be a proton transfer step that could occur as well. And so we have 5-membered ring, carbon 1 through 5. So we can label like that, 1, 2, 3, 4, 5. If we think about where everything else is, our carbonyl is on carbon number 2. And then our alcohol is going to be on carbon number 5. And then carbon number 5 also has carbon number 6 on it. So there's a methyl there. And then, of course, if we heat this, we could then transform it to our alpha beta unsaturated ketone, right? Form that product as well. So that's the proton that we removed. As we discussed, we could also think about removing this proton instead. If we did that, the product or the intermediate that we would get would be this guy right here. And then we would kick down and attack. And then if we number our carbons, 1, 2, 3, 4, 5, 6. So it's a bond between carbon number 2 and carbon number 5. Oops, my bad. Carbon number 3, not carbon number 2. Carbon number 3 and then carbon number 5. So 3, 4, 5. That's a 3-membered ring. Right, 3, 4, 5, and then off of carbon number 3, we would have our carbonyl, and then off of carbon number 4, we would have our O- and our methyl. But anyways, you can see it's a 3-membered ring, not going to form. Cyclopropane, very unstable. So again, intramolecular reactions, nothing new. Just remember 6 and 5-membered rings are favored. We can get more than 6, that's totally fine. Less than 5, much less likely.